Okay, so today what we're going to do is we're going to talk about sampling distributions. And we're going to start kind of like this with using these definitions that I got from the book. And then we're going to kind of use the example that we set up yesterday with all the tanks. So like the tank serial numbers, and kind of see how this relates to what we're doing today. So here's the first thing. We're going to talk about these two definitions. The first one is parameter. And a parameter is essentially the entire population. Now, a lot of times that's unknown. So in our tank example, the number of German tanks was our population. So we didn't know how many total tanks that we had, and that's kind of what we were trying to figure out. Now, a lot of times we're actually not trying to figure out the population, like the population's parameter that we normally talk about is its mean. And so like a parameter, if we were going to write the symbol, a lot of times we're going to use mu or p to stand for like the mean of the parameter that we're talking about, or the actual percent that that thing occurs. The other thing that we have is called the statistic. Now the statistic is a sample. So you want to think of the statistics as a sample, and it's the sample information that we get from the unknown parameter. In this case that we had for our thing, it was these sample serial numbers. Those were our statistics that we got to use. So that is our statistic. You want to think about statistic as sample, and our statistic for this one was like the groupings of tanks. So that for us was our like statistic. Now how this kind of works is like, because we can't write the statistic mean and p-values to be the same, a lot of times we call this statistic thing x bar or p hat. So these are the symbols that we use for the statistics, or the statistic standard like sampling distributions. A lot of times we aren't given the actual means or the actual population percentage, but if we are, those are the symbols we use. If we aren't given the actual ones and we use statistics, that would be our statistic one, or if we were using a percent, we would do p hat. So for us, when we looked at this sampling distribution, is if I found like a mean of a data set, like these would be considered my x bars that I found. And if I took the sampling distribution's mean, I would use an x bar for this, and it looks like the mean or the median would be around 200 for the sampling distribution. Next kind of thing that we have. This is called a sampling distribution. A sampling distribution is a statistic, the statistics distribution values of all the possible statistics. So we started making a statistic distribution here. Like, so you have a statistic. If you take all the possible statistical combinations and make a graph of this thing, then you actually have a statistic distribution. This thing is almost a statistic distribution. I only have 20 sets. We don't have all the possible combinations. All the possible combinations would be a lot. So there's very few times that you have all of the possible combinations, but a lot of times we have an approximate sampling distribution. So this other one that was on the other page was an approximate. Because it doesn't have all. Because we didn't have all. So if we had all, then it would be a sampling distribution. Since we didn't have it, it's just approximate, but it's a pretty decent approximation. As you can see, like the actual numbers that I used for the middle is 200, and we can see that this distribution, it's a little skewed right-ish, like it's pretty close to being symmetric, and our middle would be about 200. So even though we don't have a exact sampling distribution, this approximation is pretty good. And it doesn't look to be very biased, like one side is skewed a lot more than the other side. The last thing we want to talk about is the variability of these statistics. The variability is if you take the sampling distribution and you check the sampling distribution's variability. So if we took the sampling distribution and we found its variance, that would be the sample's variability. Now, a lot of times you want to have large sample sizes, and a lot of times we say that the spread of the sampling distribution depends on the population, and the population is at least 10 times larger than the sample. So you don't want it to be the entire population, but you want it to be a certain percentage. And because the entire population, this thing was 200, but we only chose 4, we're still within the parameters of this thing, so we're still okay. Okay, so let's actually kind of go through an entire problem or what this would look like. So it says a large pet store that specializes in tropical fish has thousands of guppies. The store claims that the guppies have a mean length of 5 and a standard deviation of 0.3 or 0.5. You come to the store and you randomly buy 10 guppies, and you find the mean length of the 10 guppies is 4.8. This makes you suspect that the mean fish length is not what they say. To explore it further, you assume that the length of the guppies is normally distributed, and you use a computer simulation of 200 samples of 10 guppies from the store's population claim. Below is the dot plot of the means from the 200 samples. So basically, we went in and assumed that, hey, let's buy 10 guppies. Let's measure their mean lengths. We'll do it 200 times. We'll see what we get. And this is the simulation that we got. So what is our population parameter? Well, our population parameter that they gave us is it's all the guppies, and it's the mean length of the guppies. And they said the mean length of the guppies was 5. So that would be our population parameter. It would be that mean length of 5. And then kind of the next kind of question that comes from this is the distribution of one sample is described in the opening paragraph. What information have we been given about this sample? Well, I would say the information that we've been given is it's 10 randomly selected, which is really good for us, guppies. So that would be one of our samples, would be 10 randomly selected guppies. We could kind of further say that the n, that's our n, or our sample size is 10. The other thing we could say is Rx bar, for this case, is 4.8. So again, this is my parameter, and this would be my sample, which would be 4.8. And again, for parameter, you want to use this mean symbol, and for our statistic, you want to use this x bar symbol. Okay, and it would ask, is this dot plot above a sampling distribution? And the answer to this would be no, because we just ran this simulation for 200 samples, and we can kind of assume that since they have several thousand guppies, that this wouldn't match all several thousand if you just did 10 sets of 200. So this isn't every combination. So it's an approximation, but it isn't every single combination. So we would say the answer is no, it's an approximation. Again, because it's not every single one. And then we could do some things on this variability. As you can see, whoops, as I drew too quick, but as you can see, this is kind of normal. I wouldn't say that the store was wrong with guessing the mean is is around 5. It's probably actually a little bit closer this way, but probably not that far off. So if we were saying, like, is the store wrong? I would say no, it's not. It seems to be centered around 5.0, even with our simulations. So I would say that the store isn't wrong. We might have just got from our sample statistic something on this lower end. So that's kind of how you do the different problems. What I've done is I've posted on Canvas the different types. A lot of them are essay questions. So try these different types of problems.